Hi, Assalamualaikum. My name is Mohamad Danish bin Zaharuddin and my metric number is A21B2583. Today I will present about the statistic assignment. Before that, I will first introduce my group member AL-EIMAN BAIHAQY bin MOKHTAR and HAZMAN bin MASBUDI. Our group assignment is a data set A. First, for descriptive and summary statistic, the secondary data set measure of central tendency, variation and position will also be calculated and interpreted in this study. The data used are the liter per 100, kpl, cylinder, horsepower, weight and brand. In this report, we will learn about the data and how it was collected, analyzed and interpreted using statistic software and theoretical model based on the data population. As you can see in my slide, they have 6 variables, which is the type of variable for liter per 100, kpl, horsepower and wages is numerical and the measurement is ratio. For cylinder and brand, type variable is categorical and the measurement is nominal. For sampling data and record categorical data, we had selected 150 observations randomly from 392 observations using data set A that has been provided. Then we had record all the numerical data as mentioned about on data description. It is easier for us to calculate the frequency.
For the next slide is a numerical descriptive measure. Firstly, for numerical descriptive measure that have a measure of center tendency and that have a 3 method which is mean, median and mode. Firstly, for numerical that we take 3 numerical which is liter per 100, horsepower and weight. Firstly, for liter per 100, mean for manual is 6.27, for Spss is 3.8667. For median, for manual is 6.10, for Spss is 4.0. And mode for liter per 100, manual is 5.61 and for Spss is 3.0. Next is horsepower. Mean for horsepower manual which is 1.32 and for Spss is 3.6400. For median, manual is 1.28 and for Spss is 4.0. And mode for horsepower manual is 1.34 and for Spss is 4.0. Weight median weight for in manual is 3.84, for Spss is 3.6667. For median, manual is 3.73, for Spss is 3.50. And mode for manual is 3.09, for Spss is 1.0. Description. The data of mean, median and mode shows the difference result because the Spss cannot read the data accurately. All the data used above is already recorded. Measure of position. So that have a 3 method for measure of position, which is quartile 1, quartile 3 and interrange. Firstly, for liter per 100, quartile 1 manual is 5.17, for Spss is 3.0. Next is quartile 3, for manual is 10.11, for Spss is 5.0. Interrange liter per 100 for manual is 4.94 and for Spss is 2.0. Next is horsepower. Horsepower in quartile 1 manual is 0.96, for Spss is 2.0. Quartile 3 manual is 1.48 and for Spss is 5.0. And last one for interrange by horsepower, manual is 0.52 and for Spss is 3.0. For weight in quartile 1, manual is 4.23 and for in Spss is 2.0. Quartile 3 manual is 3.28, Spss is 5.0, and lastly, in the range for weight, manual is 0.95, and for in Spss is 3.0. Description. Standard deviation and variance show different result because the error of system in Spss to analyze the data separately, which is the data class interval is too large. All the data used above is already recorded. Measure of variation. So in measure of variation that have two method, which is a simple variance and standard deviation. Firstly, for liter per 100, simple variance manual is 73835.46, and for Spss in 1.781, and for standard deviation for manual is 271.37, and in Spss is 1.33445. Next, for horsepower, simple variance manual for horsepower is 3374.85, for Spss is 3.292, and standard deviation manual by horsepower is 58.09, in Spss is 1.81448. And numerical for weight, for simple variance manual is 85.99, and for in Spss is 4.251. And lastly, standard deviation manual for weight is 7375.99, in Spss is 2.06169. Description. The result Spss for data simple variance and standard deviation is not the same as manual because the Spss cannot read the data accurately. All the data used above is already recorded.
Next, graphical representation by manual and Spss. All the above drawing graph is using group data and it is plotted with an x-axis and y-axis. The x-axis represents the midpoint as the same as the drawn graph. The both type of graph shape of the distribution is bell shape, which is symmetric.
Hypothesis testing. Okay, first of all, t-test for pair 1. Our P1 is LP100 and pair 1 is LP100 and HP. Okay. Step 1, HO and HA at treatment means are not the same. Step 2, significant level denoted by A equal to 0.05. After that, we test the statistic using t-test. Step 4, fail to reject HO if T bigger than TA by 2, critical region T0.05 by 2 equal to T0.025 equal to 1.69. Decisions, since T bigger than TA by 2, 1.62 smaller than 1.96, fail to reject HO, and we can conclude that the two sample means are equal or there is no significant difference between the two sample means. The test for the next pair, which is HP and weight. Okay, same as before. HO and HA at treatment means are not the same. After that, the significant level is A equal to 0.05. After that, we test the statistic using the t-test. First, step 4, reject the HO if T bigger than T by 2, critical region T0.05 by 2 equal to T0.025 equal to 1.96. Okay, decisions, since T smaller than TA by 2, negative 0.12 smaller than 1.96 failed to reject HO, and we can conclude that the two sample means are equal or there is no significant difference between the two sample means. ANOVA. Okay. Pair 1, we matches the liter per 100 and horsepower in one pair. Okay. Step 1, HO and HA is not the same, and then step 2, significant level A equal to 0.05. After that, we test the statistic using ANOVA. That decision rule, reject HO if F bigger than FA, V1, V3, critical region F 0.057, 142 equal to 3.7854. Okay. Step 5, reject HO since F bigger than F 0.057 142, which is 27.297 bigger than 3.7854. Therefore, there is significant difference among the treatments. Okay, the next pair, liter per 100 and weight. Okay, first step, HO and HA is not equal. Okay, significant level is A equal to 0.05. Okay, after that, decision we test the statistic, and then decision rule, reject HO if F bigger than FA, V1, V2, critical region the equal to 3.7854. Okay, reject HO since F bigger than F 0.057 142 28, which is 28.749 bigger than 3.7854. Therefore, there is significant difference among the treatments.
Correlation analysis. Explanation. The value of R between LP100 and horsepower is 0.742, which show the strong positive correlation. R value LP100 and weight is 0.725, in which shows the strong positive correlation. The value R between horsepower and weight is negative 0.743, which is shows the strong negative correlation. Confidence interval. For confidence interval, we take only 3 of numerical, which is liter per 100, horsepower and weight. For confidence interval, that things have mean 95% confidence interval for mean, lower bound and or upper bound, 5% trim mean, medians, variance, standard deviation, minimum, maximum, range, interquartile range, skewness and kurtosis. Explanation. The mean for liter per 100 group is 3.8667. The upper bound is 4.0820 and the lower bound is 3.6514. The difference between upper and lower is 0.4306. The mean for horsepower group is 3.6400. The upper bound is 3.9328 and the lower bound is 3.3472. The difference between upper and lower is 0.5856. Next, the mean for weight group is 3.6667. The upper bound is 3.9993 and the lower bound is 3.3340. The difference between upper and lower is 0.6653. Prediction modeling. Explanation. Figure above shows the association between liter per 100 horsepower and weight. There is a high level association between liter per 100 and horsepower, liter per 100 and weight, horsepower and weight. Among the independence variable, there is a high level association between liter per 100 and horsepower. Correlation. Explanation. Liter per 100 correlates highly with horsepower and weight. There is no significant correlation between liter per 100 with horsepower and weight. Horsepower correlates highly with liter per 100 and weight. There are no significant correlation between horsepower with liter per 100 and weight. Weight correlates highly with liter per 100 and horsepower. There are no significant between weight with liter per 100 and horsepower.
The explanation is the R square value is 0.632, which means 63.2% of the variation in liter per 100 can be explained by horsepower and weight. The adjust R square is 63.2%. The Rubin-Watson is 2.230. Next, the explanation. The p-value from the ANOVA table is less than 0.001, which means at least one from three variables, liter per 100, horsepower and weight.
Coefficients A. Explanation. The equation is liter per 100 equal to 4.857 plus 0.137 for horsepower plus 1.08 for weight. Thus, for every unit decrease in horsepower, liter per 100 is expected to increase by 0.137 provided the other variables is remain unchanged. Based on the standardized coefficient beta, the effect of horsepower 0.187 is almost 0.02 higher than the weight 0.167. The p-value of place is less than 0.05. Thus, place is significant predictor. The 95% of C1 for place is 0.056 and 0.219, where the value of 0 does not fall within the interval, again indicating place is a significant predictor.
And last, the conclusion. Set A include liter per 100, kpl, cylinder, horsepower, weight and brand. Spss statistic is IBM software for data management, advanced analytics, multivariate analysis, business intelligence and criminal investigation. We use IBM Spss statistic to randomly record 150 observations from a data file to sample and record categorical data. In the presence of a table, we pass the data set using central tendency, position and variation measure. Manual calculations are used to determine the mean, median and mode of liter per 100. The mean is 6.27 and the median is 6.10. The mode is 5.61. The SPSS calculation for liter per 100 found a mean of 3.8667, a median of 4.00 and a mode of 3.00. SPSS can accurately read. Prediction modeling is used to test the theoretical model and explain its relationship. Graphs show confounding model and pattern and how different variable model control for confounding. Distribution shape are symmetric and non-symmetric. Normal and skew distribution are symmetric and asymmetric. Symmetrical distribution have mirror image site. Normal distribution is symmetric distribution of observed values. Non-symmetric distribution don't have mirror image site. Skewness is the tendency for x-axis value to cluster. That's all from us. Thank you.